Hello everyone, I'm Rakibul Hassan Bhuiyan and I will be presenting our paper with my co-authors from Bangladesh. Our paper title is A Sustainable Homestead Prototype in Sundarbans, Disaster Adaptability through Alternative Building Materials. This paper is mainly the documentation of the analytical approach to design a homestead in the context of Shyamnagar Upazila Satkhira near Sundarban. The Sundarban is a unique region with its biodiversity and a special ecosystem. Sundarban's resources and the location of the households in the forest formulated the socio-economic structure that now prevails in the jungle. The human settlers of the forest go by their social structures, and most of their regular livelihood depends on the welfare of the forest community. Due to its geographic location, the largest piece of uninterrupted mangrove habitation of the world is a highlight for many natural disasters. The common natural hazards that the Sundarban region faces regularly are frequently occurring cyclones, irregular flood, the ever-rising sea level that is causing the decreasing land area of the forest. The aim of the research is to propose an alternative solution to build a homestead prototype with structural adaptability. The objectives are to achieve affordability, material reusability, sustainability, creativity, resilience, and implementability. The analytical approach of our research started with the literature survey and then progressed further through the field surveys. In this process, the social, economic, and environmental aspects were gathered, combined with the architectural practice that were present in their typical community structure. All their collected data and findings pointed to the special factors that a homestead in a unique context, such as the Sundarbans region, needed. Then the search for alternate materials that can withstand or can be arranged after a disaster was explored. All these materials were assembled into a courtyard-based design style respecting the already practicing homestead in the region. Overall, a climate-resilient and context-friendly approach was taken to provide for the disaster-affected people through a cost-effective design. The building material study went through some typologies which were done in our field survey. The building materials were studied using the housing modules as clusters and analyzing how different materials serve the need of the typology and what the benefits and the limitations of the materials are in the context. Here, typology 1 is related to such buildings whose mud wall acts as a load-bearing wall, generally has the bamboo structure to support the thatched roof using golpata. It is mainly for the low-income people. This building shape is rectangular, generally 10 feet into 15 feet. Its plinth level is generally raised at 2 feet or more. Another typology building mainly suitable for middle income groups, where bamboo and wooden post or prefabricated concrete post is used as a structure, and wooden planks or corrugated sheet is used as a wall, where the roof is made of corrugated metal sheet. Its plinth level is generally raised at 2 feet or more, which can be covered with mud or cement. For affluent families with a high income group, this typology is seen using a complete brick structure with a cement overlay and plastered brick wall. The roof of the plinth are similarly corrugated and the generally raised at 2 feet or more, which can be covered with brick or cement. This building is of various sizes. Among different typologies, we saw some similarities between the spatial distribution. The houses can be accessed from the courtyard, but not from the adjacent road. The traditional approach is the formation of an inner semi-private courtyard, which is one of the most important factors in the rural homestead. Besides different domestic activities, it also serves as a playground for children and a space for communication between households. Ponds are generally on the backside and is used for water. Generally, the shops face the road, which is used for different economic activities and can be an extension of the house. The vegetable gardens are also very important element of the homestead, which are used and maintained by the families for water and food. From studies, we identified some contextual problems and some possibilities of the mitigation strategies. Problems such as the occasional rise of water level due to tide, even with raised plinth, the houses get submerged. In this case, a floating structure can help to adapt the both water rise and the flood effects. Though the brick buildings in typology 3 can withstand the storms, due to affordability problem, they cannot be widely practiced. A possible mitigation strategy can be proper structural adaptability with low-cost materials. Considering the material durability, mud, golpata, wooden post, etc. deteriorate due to water submergence and rain. A durable material or proper treatment of natural material can increase the durability, and it can therefore be used. From these problems and mitigation strategies, we identified some design components that we used for further exploration of the alternate building material. For the floating structure component, we explored plastic drums and inflating rubber. Both of these have positive aspects and negative aspects, but the plastic drums are the better option because of its durability and recyclable capacity. For the structural adaptability component, we explored bamboo, timber, and prefabricated concrete columns. Considering the pros and cons of the three materials, bamboo under treatment is considered a better option because it is durable, affordable material, and it gives the proper structural rigidity. For the durable wall and floor material component, we explored plastic brick, bottle brick, and burnt clay brick. But plastic brick is chosen as a better option because of its durability and upcycling capacity of waste plastic. We try to explore how we can build a prototype using alternate building materials. Our design addressed the proper connection between floatability and structural rigidity. With the ground floor floatable only and the structural component properly fixed to the ground by concrete footing, the semi-amphibious structure can effectively withstand both strong cyclonic wind and flood at the same time. Within an area of 1,000 square meters, the covered and semi-covered activity spaces together are 140 square meters. The remaining spaces are divided into courtyard and other open-to-sky activity spaces. One of the features addressed here is incrementality. The living area module can be incrementally grown into two phases, from phase 1, which is 72 square meters, to two-storied phase 2, which is 108 square meters. The basic phase 1 module is appropriate for a single family with provisions for workspace and all the basic amenities. In the later phase, the area of the storage workspace and the structure goes through the transition of growing vertically to meet the needs of the inhabitants. Modularity is another important aspect. The 2 meter into 2 meter grid is followed in the module layout, which creates a scope for the integration of semi-open and covered spaces in the harmonious way. The dimension of the rectangular housing module has been obtained from the typological study of the local vernacular housing scenario and the capacity of bamboo as a structural element. The outer plastic brick walls remain fixed with the bamboo structure, and the inner walls have vertical folding mechanism which have attachment with the floor and with the bamboo beams. In normal period, the walls can remain straight, but in case of flood events, the ground floor floats and the walls fold. Up to the water level rise, the 9 feet water level rise, the ground floor can be used, providing continuity of daily activities. We can see that the inner walls only fold, but the outer walls remain fixed. Finally, we can say that the research focuses on achieving sustainability through disaster adaptive measures. It is a documentation of the design approach taken in an analytical way for the design of a homestead prototype through the exploration of existing and alternative building material and vernacular practices. It is the result of a non-experimental process. Further discussions can be conducted for having an experimental research based on the results found in similar contexts, and observe the upgrading of livelihood and the empowerment of the community. Thank you for your patience. I hope you have enjoyed our presentation. Thank you.